So welcome back to another application. This one's not scientific, but it is an interesting word problem. We got the total healthcare costs in the United States in 2003 was $1.7 trillion. The U.S. population was 290.9 million. So the question is, what was the average amount spent per person on healthcare? So that's what we're looking for. What was the average amount spent per person on healthcare? So again, before I can really grasp this problem, these numbers are a little strange to me. 1.7 trillion, 290.9 million. I don't know if I can write those numbers out. I'm going to play with that for a little bit. But let's look at something a little bit more simpler. Let's suppose that we're dealing with $100 and there's 20 people. How would I find the average cost per person? So what I pick up on is, if I have $100 altogether and I'm sharing it among 20 people, that average cost sounds like it's going to be a division problem. So 100 divided by 20, so I get $5 per person. So on average, each person is going to be using $5 of that $100. Okay. Now the reason they kind of say average cost, because if you've ever been involved, some people are a lot sicker than others. Somebody may not even use any health care throughout the year, but they're part of the population, while others, unfortunately, are sick and they do have to use the health care system. So that's what they mean by average cost. We don't all pay, we don't all spend the same amount on our health care. Some of us, like I said, aren't sick, we're lucky, we're healthy. Others, meanwhile, do not have that luxury of being healthy and need our healthcare system. So this average cost, what we're picking up on, this is a division problem. So what I'm picking up on then is, in our problem, the cost, the money was $1.7 trillion. And we're going to divide that by the number of people, which that's what population implies, is the number of people was 290.9 million. So that's what we got going on here. But how in the world do I even input that into a calculator? What's 1.7 trillion look like? Well, let's look at this. Based on our place values, we have ones, tens, hundreds. Then we have 1,000, 10,000, 100,000. So this is our thousands place. Then we have, after thousands, we have 1 million, 10 million, 100 million. So this is our millions place. 1 billion, 10 billion, 100 billion. So this is our billions place. And then we have 1 trillion, 10 trillion, 100 trillion. So it looks like the trillions place starts here. So that means we have to put on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 12 zeros to be there. So 1.7 trillion means 1.7 times 10 to the 12th. Because if I put that 10 to the 12th there, that's going to move my decimal 12 spots out, and that's going to get me my place value to the right spot there. So if I want 290.9 million, well, the million spot begins right here. So that means to be in a million spot, I got to go 1, 2, 3, 4, 5, 6. I got to put 6 zeros in there. So that's going to be 290 point. Oops, let me try that out a little bit better. Find me a marker, eraser. So that's going to be 290.9 times 10 to the 6th power, because I need those 6 zeros there to get me out to the million spot. So now I can kind of play with this problem. Notice how, again, I can work with these. These have the same basis. I can divide that out. If you have 12 tens on the top and 6 tens on the bottom, that's going to leave me 6 tens. So what I'm picking up on is I have 1.7 over 290.9 times 10 to the 6th power. So it looks like the math I need to do is 1.7 divided by 290.9. So 1.7 divided by 290.9. That's going to give me, well, it's going to be a strange number again. I'm going to go out to 4 decimal places. So it's going to be 0.0058 times 10 to the 6th power. Okay? So now, to really make this look relevant to us, we're talking about cost. Cost probably does not need to be in scientific notation. Let's put that in what we call decimal notation. So times 10 to the 6 means to move the decimal 6 places to the right. So I got to move 1, 2, 3, 4, and 2 more zeros. So it's a 5, 8, and 2 zeros. So when I pick up on it, it's going to be $5,800 per person. So that's what healthcare would have cost us back in 2003 if we take it all in holistically. On average, each person is putting in $5,800 to help with the healthcare. That doesn't mean I'm spending $5,800, but if you distribute it evenly across there, it would play out to $5,800 per person. So that's how we can attack that problem. So first off, we had to find out that relationship. We had to pick up on, hey, this is a division problem. But we had to figure out a way to write 1.7 trillion on paper. And we picked up on that the trillions places out here, that's 3, 6, 9, that's 12 spots over, 12 zeros. So I need that 10 to the 12th to get me out to the trillions place. And the same thing with the millions place. I had to get to the millions place, so I needed 6 zeros there. That's why that 10 to the 6th is there. Now I can kind of play the math out and get my answer of $5,800 per person. So that's some fun math there. That's got some challenging, and I wish I said pause the video before we started here, and you could have tried to play that on your own. So I hope you enjoyed that. That concludes our exponents. I think we have some things on what we call polynomials is coming up in the near future. So stay tuned for that. I'll get that out as soon as I can. I'm going to go on spring break, so I hope you all enjoy some time off yourselves here.